So now we're going to start to transform the trig graphs. We're going to focus mainly on sine and cosine, but we'll look a bit at trig. So if you remember, normally I'd be doing this the next day. So when I say if you remember, it would have been 24 hours ago. For you guys, it was 15 minutes ago. But the sine graph looks like that. There's sine of x. That's pi, that's 2 pi. Cosine graph starts at 1, starts at a max. Looks like that. That's an exaggeration, but whatever. Pi, 1, -1. And they both oscillate between 1 and -1. So this first one is just going to look at a values at the beginning. Okay. No, we're going to look at a and b's. So, okay. What we're going to do is we're going to use that equation from transformations. If you remember this, y is equal to a f b x minus h plus k. Now, a and b's will stay the same. Right? You can see them, they put them into the same functions. Instead of calling it h, they now call it c. Instead of calling it k, they now call it b. You could write any letter in there, it doesn't really matter. Okay, it's where it is in the function that's important. Okay, but we're going to save the d's and the c's for the next lesson. This is lesson 8. We'll look at in a bit. So this first graph, 2 sine x. What is that a? I just told you. It's a 2 value. A is 2. What does it do? I guess is what I wanted to say. Yes, so a is 2, therefore it's a vertical stretch by 2. And you can see on actual graph, here's the sine function. And if I put a 2 in front of it, boom, it just expands. All right. The amplitude is now 2, and the range is -2 to 2. That's all it does. Pretty straightforward. What about this b value? What's the b value, guys? The b value is 2. What does that do? By 1/2, right? Remember, you flip the b value. So this is a horizontal stretch by 1/2. So it should compress it. So if we go back to Desmos here, and I erase, come on. Delete. I put a 2 there. It shrinks it. And actually I should, yeah. You can see that it has compressed it like this, okay? If I put it right next to a sine function, the blue one is the regular sine graph. Okay, so the peak is here. It's been moved by a factor. Okay, so it's just squished it like an accordion. What about this one? -3. What does that do? By 3. And what's the negative do? Over. There you go. So a is -3, so we get flip over x-axis and bs by 3. All right, 4. The b value of -3, so what do we get? What happens? Flip over y. And s, horizontal stretch by 1/3. So it has compressed it and flipped it. All right. So we're going to go to here, this table. Sine x, regular straight up sine graph. What's the amplitude? 1. What's the period of a sine graph? It's right there. Boom. 360 or 2 pi, right? I'm going to do it in pies. We'll do both, okay? 2 pi or 360. Okay. If I put a 2 in front of it, remember, what did that do to the graph? It stretched it vertically. So what's the amplitude now? 2. Did it change the period? Did it squish it or expand it or anything like that? No. So the period stays the same. 2 pi. Sine 2x. Did the amplitude change? No, because it didn't do anything. So it's still 1. What about the period? What did we do to the graph? We compressed it, right? By a factor of a half. So the period was 2 pi. Now it's pi. Okay. -3. What's my amplitude? Okay, what does the negative do? Why? Yeah. So if you flip it and stretch it, it'll look different. Right? The peaks and everything are all switched in terms of where they are. They line up this way. But the max and the min are still essentially the same thing. Okay, so it's +3. The amplitude's never negative. +3. Did we change the period? Nope. It's 2 pi. All right, next one, sine -3x. Did we change the amplitude? Did we change the period? What is it? If we went from a period of 2 pi to pi when our b value was 2, what do you think this one is? Pi divided by 3. You divide the period by your b value. So tell me the amplitude and the period for this guy. 5 sine 4x. 5 is the amplitude. That's right. What's the period? 2 pi over 4, which would reduce to over 2, or 90 degrees. All right, and last one. I'll let you do that one. Period is 1/3. Sorry, amplitude's 1/3. Period is pi over half, which is 4 pi. Right? If I go 2 pi divided by 1/2, you flip the bottom fraction, and you get 4 pi. Okay. So in general, your amplitude is your a value, and your period is 2 pi divided by b. Or if you want to do it in degrees, 360 over your b value. Which, when you flip the page, are in a nice little table for you. Right there. Okay. For sine and cosine, we've already talked about the amplitude. So this is good. This formula here is for graphs. Because if you have a graph, you can look at the max and the min and you can determine the amplitude, right? If you have an equation, it's just the a value, but it's the absolute value of the a value, i.e., your amplitude is never negative, okay? For sine and cosine, the period is 360 over b or 2 pi over b. Again, ignore the negative, all right? For a tan graph, the amplitude doesn't make any sense because you can't pull it off of a graph, right? But I can give you an a value. I can write y is equal to 3 tan x. That means we've stretched it vertically by a factor of 3. So it'll rise faster, but there is no amplitude because there's still no max and min. It goes on forever, okay? So if I gave you that question, I would expect that you just go, well, a is 3. But it's not the amplitude because there is no amplitude in a tan graph. So that's the key one there. The other one, I'm going to ask you a question like this, and at least some people mess it up every year. I will ask for the period of a graph, a tan graph. So I will give you something like this, and I'll say, what's the period of that tan graph? And everybody, I shouldn't say everybody, sorry. Some people will go, well, period is 2 pi over b, and they'll tell me it's pi. But because it's a tan graph, it's pi over b. So the period of this would actually be pi over 2, okay? So that's a key. For tan graphs, the period is pi divided by b, or 180 divided by b. Remember that, please. All right. Going once, going twice. Normally we'd sketch that. COVID, we don't. All right. So we're going to write the equations, given some information. We are only using a and b right now. So the general formula is a sine b of x, or a cos b of x. All right. Sine function having an amplitude of 2/3 and a period of pi over 6. So if I tell you the amplitude is 2/3, what's your a value? 2/3, right? That's boom, done. We are a sine graph. Period is pi over 6. Now, remember, period is equal to 2 pi over b, okay? So if you go, period is equal to 2 pi over b, I tell you the period, you have to find the b value, okay? So that means pi over 6 has to equal 2 pi over b. So you gotta do a little algebra. Multiply the b up, multiply the 6 up, divide off the pi. You will get b is equal to 2 pi times 6 over pi. The pi's go bye-bye, and you're left with 12. So your b value is 12. And then you just plug it into this formula. So it's y is equal to 2/3 sine 12x. We okay? All right, cosine function has an amplitude of 3 and a period of 720. Amplitude 3, therefore a value is 3. Don't have to do anything. Period is 720. Talking about cosine functions. So remember, period is equal, since they gave it to us in degrees, we're going to use the degrees. 360 over b. So that means 720 is equal to 360 divided by b. Therefore, b is equal to 360 over 720, which is 1/2. So then you just plug it into this equation. 3 cos 1/2 x. Good? All right. Tangent function has a period of pi over 2. They don't say anything about amplitude or a value, so we don't just assume it's 1. My period is pi over 2. What's the formula for a period of a tangent graph? Pi over b. So the period is pi over b. I've told you the period is pi over 2. Therefore, b is equal to 2. What's tan 2x? Is that okay? Once, go twice. All right. Before we do the last bit, I'd like you to do 1 to 7. I can only give you 10 minutes, maybe 15. 5 to 11. Then we'll move on, please. All right, now they're giving us a graph. They want the amplitude period and then the equation. So they're telling us it's a sine function. Okay. The general equation will be a sine b of x. We need to figure out a and b. So the amplitude, looking at the graph, what's the amplitude? What's the max of this graph? 3, right? And the min is -3. So what's the amplitude? 3. Could go max minus min if you wanted. So it'd be 3 minus -3 over 2. 6 over 2, you get 3. Okay. What's the period of this graph? Here. The peaks and the troughs don't occur at nice numbers, okay, or they're not marked. So what we can do is you can either go from here, because the graph is falling at that point, to the next part where it's falling and marked, which would be that. Okay. And then just find the difference there. So you could go 3 pi over 2 minus pi over 2. We're subtracting fractions. We have a common denominator. So we get 2 pi over 2, which is just pi. Do we agree with that? Okay, that's one way to do it. Pi. The other way, and sometimes this is valuable, is if you realize that each line here is worth pi over 2 units, right? And if I start here and this is rising, the next rising part is 2 units away. So it would just be 2 times pi over 2, which is just pi as well. I don't care how you do it, but just I'm giving you a couple different ways to figure it out. All right. So now I know the period, but I need to know b. How do I find b from the period for a sine function? Period is equal to 2 pi over b, right? That thing right there. So if I go period is equal to 2 pi over b, my period is pi. Therefore, what's my b value? So now I know a and I know b. So the equation for this graph is 3 sine 2x. So now you're able to take a trig graph and, generate an equation. And once you have the equation, then you can solve a lot of problems, okay? or questions, I guess. Is that okay? Want to do one more? All right. So these are called sinusoidal graphs. Okay, just means that they're repeating graphs. That's all it means. They are used to model a lot of different things. So one of them would be tides, because tides come in and out, and you can measure the max height and the min height and everything. And normally there's a section on word problems, these next lessons. We're not doing those just because of time. But this gives you a brief little glimpse into that. So this graph represents the average sea level over a 24-hour period. It's a cosine graph. All right. They call it h for height and t is for time instead of x. Okay. T is in hours, h is height. Determine the equation of the graph. Okay. So the first thing we have to do is we need to figure out our a value. What's the a value of this graph? 4. Thank you very much. Then we have to figure out the period. Okay. What's the period of this graph? 12. Each line is 3. If you measure the distance between those two, that would be 12 right there. So the period is equal to 12. Now, we need the b value. So this is where you have a choice. So remember we said that period is 2 pi over b, or it's 360 over b. Which one of those do I want to use? Do I want to use the 2 pi, the rads, or do I want to use the degrees, 360? You want to use rads. Do you know why? There you go. That's it. The graph is not in degrees, it's in time. Okay. Remember, rads does not have units. All right. So if this is not degrees, the x value, the x-axis, you must use rads. Okay. So we're going to take our period and we're going to set it equal to 2 pi over b. And then we're going to solve it and get b is equal to 2 pi over 12, which is pi over 6. So there's our b value. We've got our a. We're going to plug it in to get 4 cos pi over 6 t, and that should be an h, not a y. Just to be proper, h of t. So that's the equation of the graph. Now, if I asked you, what is the height at, I don't know, 4 hours? What is h when t is equal to 4? This question isn't asking you that, but I'm making it up. What do you do? Where does the 4 go? It goes in for t. So you're going to get h is equal to 4 cos pi over 6 times 4, and all that is inside the trig function. Now, when you do it on your calculator, what mode must your calculator be in? Radians, right? So I want everybody to tell me the answer here, please. Did we get -2? All right, perfect. So when you get asked a question like that, just make sure that your calculator is in the right mode. I.e., if it's a question like this, it has to be in radians. Is that okay? One other thing that'll help you on question, I think 7, question 10, this will help you on. So if I have a graph and I give you this, and I say, what is the period? What's the problem with the information I've given you here? What do you need to figure out the period? Yeah, you need like 2 peaks, right? Or 2 troughs or whatever, because it's how often it repeats. I've only given you a max and a min. But what do you know? You know how long it took to get to here, right? So how long is it going to take to get back to the max? 2 times that, okay? So if I give you half, I just give you half the graph, the max and the min, the period will be 2 times, I'll just write pi over 3 in this case. So it'd be 2 pi over 3. But it's 2 times the distance. That I wanted to write. 2 times distance between max and the min. That will help you with question number 10. So I'd like you to do 8 to 10 and then 12. I'll give you 2. Well, I only give you 10 minutes. Sorry.